Hello everyone, today I'd like to discuss about a new problem and its solution using dynamic programming approach. So as you can see, the name of the problem is Maximal square. So let's get started. Let's see what does this problem say. It says that given an m into n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. As you can see in the example, we'll be given a 2D array, or simply saying matrix, having different length and width. That means the number of rows may be different and number of columns may be different. They may not be equal all the time. Now in the matrix, in each cell there will be either 0 or 1. What we need to find out is the area of the largest square containing only one, or simply saying we will have to find out the largest area of adjacent ones, provided that that area is a square. So here in this example, as you can see, the red mark in the first example, the red mark area, you can see this area, this is on this area only has one, and right to that one, the one marked with green color, both of the square has an area of 4. So this is the area of the largest square. So we need to find out this thing. Here is an example array. As we already know that in dynamic programming we can solve the problem using tabular approach. That means we need to take a table or array, whatever it is, and update the value of each cells of the array or table using the help of its corresponding values, which we call it a recursive relation or recurrence relation. And the very first value is the base case. In this problem, what we need to do is we need to allocate our area with a new array or matrix, whatever it is, then find out the base case and then find out the recurrence relation. Then we can solve this problem. At first we need to take a array. Let's say the name of the array is dp, and let's say we will initialize the dp array with 0. Talk about the base case. Since we are talking about a square, the minimum cell required to form a square is 1. So here, when the row, for the first row, say this one, and first column, the only possibility of having a square is having a single cell. That means in my dp array, the very first row and first column will have similar values that of the matrix. That means in the first column we will have 1 1 1 and 1, because this is one of our base case. And in the first row we will have similar to that of the first row of the matrix. That means 1 0 1 0 and 0. Now what we are left? We are left with the recurrence relation. You may pause the video here and think about this recurrence relation. This is the most important part of this video. How I am gonna solve this problem is, I would like to find out the length of the one side of the square. If I simply find out the length of one side of a square, then simply the area of the square will be the square of that value. We have come to a conclusion that we'd like to find out the length, provided that all the value or all the cell of the square has 1. We'd like to find out the length of a side of that square. We'd like to store the length in each cell. Here, by storing the length, I mean I'd like to store the length at the very bottom right corner of the square. So suppose if this is a square composed of 4 cells, the length of the square will be kept in the, what did I say, bottom right corner, in the corresponding value of the dp. That means here we would like to store the length of the corresponding square. In this way we would like to fill up all these values, and we'll simply take the maximum value. The maximum value will be the length of a side of the largest square. Suppose in this cell, how are you going to find out the length of this square? If I take this cell will represent simply the length of this square, and the value will not be here, the value will be the corresponding cell of dp matrix. That means here we'll apply a condition before using this recurrence relation. Is we will apply this recurrence relation in case of the cells which are having only 1 as value. We will not think about the cells which already has 0, because it already confirms that not all the cells of the square contains 1. as we have decided that if there is 1, we'd like to find out the length of the side. So we already know that the length of the square will be at least 1. We are left with this cell, and this cell. Now there may be a 0 in any of those 3 cells. So how would we like to calculate? So the calculation will be this. That means in the ith and jth index of the DP, we will take the minimum of these 3 values and add 1 with it. If we have a look at this square, since all the values contain 1, that means here this mean value will return 1 and we will add 1 with it, which means that the length of a side of the square will be 2. Now let's go to our algorithm. At first, what do? We take a 2D array named DP. When we declare the DP array, we simply initialize all the values as 0. Then we satisfy our base case. That means the very first row and first column of the DP array would be same as that of the matrix, given matrix. We declare a variable that we will return, so we take it as 0. Why are we taking it as 0? Because we are guaranteed that no value will be negative, so we can simply initialize it as 0. Now we simply iterate over each cell of the 2D array. If the value of the matrix at that index at that particular cell is 1, or then we simply apply our recurrence relation, that is this one. Now what do? As we need to return the ultimate answer to the max side, that means which contains the maximum length, so we simply compare it with the dpij index like this. And when we are done with iterating with the array 2D array, we simply return the square of max side, that means this. Now let's solve our this, or let's simply apply this algorithm of the given array. At first we simply let us suppose that currently all the cell of the DP array are 0. Now we initialize the first row and column, that means we simply satisfy our base case. What will be our base case? We check for the remaining cell and calculate the length of the square which contains all cell as 1. So what do we see? We say that if matrix ij equals 1, then we will apply it. Currently we are at this index. Here it is 0, so we don't do anything. Currently we are at this index. Here we have got a 1. Now we will apply our this recurrence relation. There is 0, so this minimum will return 0 plus 1, so we have 1 here. We check the corresponding these 3, this one and this one. So here there is 0, so minimum will return 0 and we add 1 with it, so we get 1. Now we go to this index, the corresponding index in the matrix got 1, so we will repeat the same procedure. Here we have 1 but 0, so that means we will have simply 1. Now we go to this index, we have got another 1, so we check the corresponding 3 cells. There is already, if there is a single corresponding cell contains 0, we simply get 0. So there is 0, so 0 plus 1 will be 1 for this index. Now we go to this index, that means this one, there is 1, so we again compare. One cell contains 0, that means it will be 1. We come to this index, it also contains 1, so here there is also a 0, one cell, so we get 1. Now look carefully, this cell also contains 1, but if we have a look at the corresponding 3 cells, what do we see? All the cells contain 1, so the mean will return 1 and we will add 1 with it, so we get in this cell 2. Now we go to the next position, that means this one. Here also, here what it is, no cell contains 0, so here the minimum value among these 3 cell is 1, so we get 1 from this and we add 1 with it, that means we get 2. Now go to this index, these are 0, we ignore it, so here the very first initialized zeros remain. We again got a 1. Let's see, here we have 0, so we need not to think about this, we get 1. Now the last one gets is there is 0. So what do we get? What is the maximum value we get from the DB matrix? That is 2. So we simply return the square of the 2, that means 4. Now let us check the maximum, the area of the largest square containing 1 is 4, this one and this one. We have successfully completed applying the algorithm to this problem array. Let's try to solve it in Leetcode using C++. This is our problem in Leetcode. Let's run this. We got a success and our runtime is faster than almost 98% of other C++ submission. Page time is faster than almost 48%. There is a brainstorming task for you. Here, our required space complexity is O of m into n. Can we reduce it? If you can, then maybe you can tell it in the comment section. So guys, that's all for today.